Okay, this is the next question. This is the next question I am taking. Here T flip-flop is used. Here T flip-flop is used. Find the output frequency. Find the output frequency. Okay. So what we know here is T flip-flop is used. T flip-flop is used. Okay. And negative edge triggering is used. Negative edge triggering is used. And then input clock frequency. Input clock frequency is 10 megahertz. Input clock frequency is 10 megahertz. Okay. I am drawing the clock signal. I will do it carefully. I am drawing the clock signal. Okay. Positive, negative like that. And the circuit will operate at the negative edge triggering only. Negative or falling edge only. This is the clock waveform. At falling edge operation will happen. And if you see the truth table of T flip-flop, if you see the truth table of T flip-flop, when T equal to 1, output is toggling, previous state output. Okay, previous state output, it changes to the opposite value, okay, in the next state. Previous state output, it is changing to the next value, okay, opposite logic in the next state. So toggle happens when T equal to 1. In T flip-flop, toggle happens when T equal to 1. So now if I draw the if I assume initial value output is 0, if I assume initial value output is 0, you can assume anything. It may be 0 or it may be 1. You can assume anything. I am assuming initial value equal to 0 for the T flip-flop. Initial output value equal to 0. Okay. So I'm assuming let Q equal to 0 initially. Q equal to 0 initially. So initially it will be 0. Whenever negative edge is coming, it will change to the opposite height. It will change the opposite. It will change to the opposite logic, and it will change to the opposite logic. Okay, this is a waveform for output. This waveform for output. Toggle is happening because T equal to 1. Because T equal to 1 and negative edge triggering is applied. So at the negative edge triggering, we have to make the toggle in the output waveform. Okay. Now I will go with the time period. Now I will go with the time period. One positive, one negative. This is the time period for output. This is the time period for output. And if you see here, this is one time period, one negative positive. This is another time period, one negative positive for the clock signal. This is clock signal. Okay. So output time period is nothing but 2 times time period of the clock. 2 times time period of the clock. Already clock frequency is given. Already clock frequency is given. It is 10 megahertz. It is 10 megahertz clock frequency. So time period is inverse of frequency. Time period is inverse of frequency. So 1 divided by clock frequency, which is nothing but 1 divided by 10 megahertz, which is 0.1 microseconds. 0.1 microseconds is the time period. Now output waveform time period is 2 into 0.1 micro, which is nothing but 0.2 microseconds. This is the output time period, output waveform time period. Now what is the frequency for output? What is the frequency for output? Inverse of time period is frequency. Okay, inverse of time period is frequency. 1 by 0.2 micro. So micro means 10 power minus 6. If you take it to numerator, it will become 10 power plus 6 divided by 0.2. I will multiply numerator and denominator with 10. Okay, I will multiply numerator and denominator with 10. So this is the value, and 5 megahertz is the output frequency. 5 megahertz is the output frequency. I got value. Okay, time period doubles, frequency becomes half. In the previous problem also, time period doubles, frequency becomes half. Okay, this is how we have to carry out such questions. Now I am going to the next problem. I am going to the next problem. This is a D flip-flop used here. Whatever details I know, I will try to write it. D flip-flop is used here. D flip-flop is used, and positive edge triggering is used here. Positive edge triggering. You see no bubble. So if bubble is there, it is negative edge triggering. If bubble is not there, it is positive edge triggering. But if you see D flip-flop means it is a delay flip-flop. D means delay flip-flop. Whatever input you give, that will come as it is at the output. That will come as it is at the output. Okay. So initially, let me assume Q equal to 0. Initially, let me assume q equal to 0. If q equal to 0, then q bar will be 1. Q bar is nothing but 1. Complement q bar is 1. That 1 is going as input. That 1 is applied to input D. If you see the connection, that 1 is applied to input D. Okay. So from this, when q bar equal to 1, D becomes 1. From this, what will happen? It is a delay flip-flop, so output will become 1 when clock is applied. When clock is applied, okay, accordingly, the flip-flop will work. When clock is applied, flip-flop will give output. Flip-flop will work, it will give output, and input D equal to 1 will be carried on to the output. Again, if when q equal to 1, q bar will become 0. Q bar you are taking it to input side. Again, D will take the value of q bar. Q bar is 0 now. Next time it will become, if no clock is there, clock and then output. Okay, clock and then output. Initially, I am assuming output is 0. If I apply first clock, second clock, third clock, fourth clock, like that, okay, when q is 0, q bar is 1. Q is 0 means q bar is 1. This q bar is taken for the input. Okay, so now the input will be initially, now after applying this, q bar will come here. After the first clock, D will come as it is for the output 1. Now q bar is 0. Okay, that will be carried on to D. Only when clock is applied, it is taken as the output. Now output is 0. Q bar is 1. This 1 will be connected to D as per the circuit. And when third clock is applied, this D will come out as the output of flip-flop. It becomes 1. When q is 1, q bar is 0, that is connected in the circuit to D. So D becomes 0 when fourth clock is applied, and that input will come as the output. This is how it is going on. The meaning is, if you take a clock signal, okay, the diagram kindly adjust. This is a equal positive negative durations. This is the clock signal. Positive edge means there will be output generated in the circuit when positive edge is going on. Okay, and here initially we assumed output is 0. This is Q waveform, and whenever positive edge is there, it is going to change the logic, and whenever positive edge is there, it will change. Whenever positive edge is there, new output is coming. Okay, now if you see the time period, here also if you see one positive, one negative, this is the total time period of output waveform. Okay, this is time period of the clock. This is another time period of the clock. Okay, and here it is very clear, output time period is 2 times time period of the clock. Input frequency is given, clock frequency is given 10 kilohertz. From this, clock time can be calculated, which is 1 divided by clock frequency, and it is 1 divided by 10k, which is 0.1 millisecond. So this is 2 times 0.1 millisecond. 0.2 millisecond is the output waveform time period. If we want output frequency, it is inverse of time period. Time period and frequency are inverse. Okay, so 1 divided by 0.2 milli, you take milli to numerator, it becomes 10 power 3. Milli means 10 power minus 3. If you take it to numerator, it becomes 10 power 3. Multiply numerator and denominator with 10. Now this becomes 5 kilohertz. This is output frequency. They are asking output frequency. It is 5 kilohertz. Okay. Input frequency is 10 kilohertz. Output frequency is 5 kilohertz. Same thing happened. It has become half. But the only change is we are using a new type of flip-flop, and the connection in the circuit is different compared to previous 2 circuits. Connection in the circuit is different. Q bar is connected to D. That you have to understand. New logic we have understood. And then positive edge triggering is given in this problem. Okay. Just I will go on with – I will stop here.